Today we're going to see how we can use tactile force sensors to improve the efficiency and the effectiveness of a system. Tactile force sensors, what are they? Well, first of all, tactile sensing has a couple of definitions. First of all, it's the detection and measurement of a contact force at a defined point. Within this definition, we have a single force sensing element or a touch screen. And the more advanced tactile sensors actually can detect the pressure distribution across two surfaces that come in contact. So sensor technologies. I did mention the touchscreen sensor. It is a tactile sensor. We are all familiar with the technology. You press with your fingertip on the screen. Electronics can identify the XY position of the contact point. It's all nice, but this is not really a force sensor we're talking about here. First of all, it has very poor force resolution. And for the majority of these products out there, they don't actually have a resolution. It's just a switch on or off. Then the size is quite large. It's hard to visualize how you can get a touchscreen sensor, miniaturize it, and use it as a force sensor. The electronics needed are quite complicated for what we're going to be looking at here. So in overall, this is a good technology, but it's very application specific. So this is not the kind of tactile sensor we're going to be seeing today. Let's have a much closer look now at the Texcan tactile force sensing technology. First, we're going to see how the sensor is constructed, and then you can see what benefits derive from that. Here we see a blown out diagram of the layers used in the construction of the sensor. We start off with a flexible substrate onto which we print the silver electrodes. Then we'll go on and print the pressure-sensitive material. We'll print adhesive all around the structure. We'll laminate everything together, and we have the finished product, the flex force sensor. Now, the advantages of the technology. First of all, let's look at the electronics. Now, this is a very basic inverting operational amplifier circuit. The flex force sensor is modeled as a force variable resistor. It's connected to the op-amp, and the output is well known. We see the equation there, but the important thing here to notice is that the output is inversely proportional to the contact resistance. RS means the resistance of the sensor. Let's look now at the dynamic range, how much the resistance changes of this sensor with different force. Here we see the actual data from a sensor that's rated at 100 pounds. You can see that at very light forces, the resistance is in the megaohm range. In fact, when you don't apply any load, it's close to an open circuit. And as the force increases, and you get at the full load, the resistance will drop to around 20 kilo ohms. Now you can see this is a highly nonlinear curve. So we see on this graph the resistance over force. What are we going to get if we try to plot the 1 over Rs against force? It is conductance. So if we draw that here, we're going to see that that curve transforms itself to a perfect line. The output of that circuit is directly proportional to the force applied. The first case is from a company called the Momager. This is a really important application. You're going to see why. It's basically a training device for palpation to make sure that the clinicians detect cancerous tissue a lot more effectively than they do now. In this particular application, it has been found that most women survivors of breast cancer, they report a detection method other than mammographic examination. So that's quite interesting. So the goal was to find a way to reduce the incidence of missed palpable breast cancers, or in other words, try to improve how the clinicians are trained and utilize the technique. So Momager, that's a private company, in collaboration with the National Cancer Institute, came a training system. I'm going to see a few more details about this on the next slides. So let's look at the Momager system here. We have a model of the breast containing simulated tumors, and this is sitting on the surface of a pad that contains flex force sensor. Now, the sensors can detect where the clinician is applying force on the breast model and how much force he's applying. The system actually knows where the simulated tumors are in the model, and it can provide feedback to the user so they can improve their technique. So the advantages of the tactile sensor technology in this application are, first of all, accuracy. You can very accurately locate the position of the fingers and the amount of force applied. Thinness, it's so thin, it doesn't really get in the way of what you're trying to measure. It's just sitting flush against the pad and in between the model and the carrier.